Good afternoon, everyone. Yeah, let's go. Am I audible? Just let me know. Okay, we'll discuss about all your queries at the end of the session. Okay. Meanwhile, just I will start. So, what we discussed yesterday, generally, what things we have discussed about yesterday. Let me revise once. So in the last session, we have started with the deep learning and machine learning, and we explored something thing of about machine learning and deep learning. After that, we gone through the generative AI models. In that, we have explored GANs, variational autoencoders, and in the last session, we have discussed NLP and transformers, right? So now we will go somewhat in deeper and practical way. Just I'm going to show that some codes, how to work on GANs. So it is a project based. So you're going to get to know how this generally GANs is going to work and what is this generator and discriminator, all these things we have discussed, right? So generally the generator, what it will do, it's going to take the noisy data, right? It's going to take some noise data and it will start constructing one by one, right? So it will kind of generate new image based on the features, okay? And as well as the part of other side, this discriminator is going to be have this discriminator. What it will do, it will understand, like it will understand, so extract some features from the image and it will carry some features. So when this generator going to start generate something, okay, then this discriminator is going to classify this one image is a real or fake. So this is a conflict is going to happen between two of them, generator and discriminator. We call it as a adversarial network, right? So generator going to generate. How this is going to generate? Let's take a small data set and just will work on it. Okay, we'll get to know how we are going to create generator. What are the layers? Also, we have discussed different layers in that generator, right? Isn't it? Do you remember, guys? So about the generator game. So today we'll see the practical. After that, we'll explore some prompting concepts. Okay. After that, we're going to explore somewhat IBM accounts. So a lot of people are facing with the issue with IBM, right? So I already said that if you're okay with that IBM, you can create and you can work. If not, you're not able to do that thing, means you can just go with the Hugging Face also. Okay, let me share my screen. And guys, you're clear with the transformers, right? Yesterday we have discussed about transformers. So just I'm going to show how to do the practically. I'm going to show that. Okay. Are you able to see the screen? My screen is visible or not? Just let me know. Yeah. Today, you're going to see how to work with the GANs. Okay. Just let me show that, and I will explain each and every part. So how this generally GAN is going to work. Okay. What we are going to do in this part. Okay. So first, coming to the GANs, so we have already discussed, right? GANs is going to have two parts, that is the generator and discriminator. First, we'll import some libraries. What are the libraries we want? Just I'm going to import that libraries. Let me take it as like let me write it as okay installations. Okay. Okay. We are going to take install some libraries. Okay. So what are the libraries we require generally to do a specific task? Means we need first I'm going to import. I think you are aware of these libraries, right? Isn't it, guys? Right? As TF, I'm going to consider. Okay. Next, yeah, from TensorFlow. Okay. What is this TensorFlow? I think you know that about how this is going to work generally, right? Going to take. Yeah. TensorFlow. So in that we are going to use a library that Keras. Okay. In Keras we have different layers. So we are building from scratch. If you want, you can use predefined models also. Okay, that's fine. If you're aware of that, you can use. Okay. So I'm going to use these libraries. Um, Let me write first. Okay. Yeah, right. This is a capital. Think right. So from TensorFlow, I'm going to get Keras. So from that, I'm going to get our models. Okay. Keras dot models. Okay. Models in that I'm going to use one of the model where it will help in the formation of sequential format. So I'm going to use sequential, one of the model which is going to deal with the neural network. We are going to use that model here. Okay. So import matplotlib to some visualize some plots. Okay, I'll show you that where we are going to visualize these libraries too. Okay, I mean where we are going to use to visualize something. Okay, plot as plt. Okay, import. Oh, sorry. All this. Okay, these are the libraries we are going to use. These are the libraries are required to do a specific task. So generally NumPy. So why we are going to use NumPy? So what it will do? All the images we are going to deal with the images. This generally GAN's going to deal with images. So these images gonna do specific tasks. Means we have images, then model not understand what this image is, right? So for that, what we'll do, we'll convert that into vectors as a numbers, and then we'll send it to that model. So to do that operations, we are going to use NumPy. So where it is one of the fastest library for mathematical operations in Python. So that is the library we are going to use. And TensorFlow, which was introduced by Google in year of 2017, so which became one of the popular in dealing with these machine learning models. Okay, and machine learning as a deep learning models. And TensorFlow, in that we have Keras layers is nothing but dense layer, flattened layer. So it will help to do some process. So where we're going to use while using, I'm going to explain about these layers. And reshape, it will help to do specific areas. So where we can convert the 1D vector into 2D dimensions, right? Because the image will have a height and width in that format. And TensorFlow, we're going to use models as a sequential model. So which is going to give the I means calculate the layer by layer. So that is the reason we are going to use this is a model. And plotting, coming to the plotting, we are going to use matplotlib as a PLT. So and also we are using operating system. So these are the libraries we're going to use. Okay. Just before that, I'm going to connect with my TP, means which is a like a GPU. So which is going to work with this image complex data. Okay. Just let me change that to TP runtime. Okay. Yeah. See, T for GPU. Okay. We are in CPU. We need to change for GPU. Save it. Okay. Now run once again. Just it is asking. Okay. Array sessions. Yeah. Okay. Let me eliminate other sessions. Yeah. So I'm just activating one on the close here. Now, yeah, reconnect it once again. Hit on that. So students వచ్చి మాట్లాడుతున్నారు. Okay, next we are going to go for the next cell. So what we are going to do here in this means. So next step, so we just imported required libraries. I'm going to take one more text just sake of understanding. So what are thing you need to use this ashes, which will help you to understand the next process. Means you're going to update what the cell is working on. So in a new user come and check your code, then he will understand what in this cell, particular cell, what is going on. It's in that format he will understand. So, and when you see after some minute some time, so you'll get you'll understand what is this generally it is doing. So in that way you need to just create so generally, if you are going to create these ashes, so you'll get to know, okay, this is a cell going to work. What the first it is saying for us, install an important library. So we are importing some libraries which are required to this project. As well as we are we are loading our data. Means if we have data, we are getting our data set into this project. So this is a cell going to work on this data. If you get any error, you will get to know, okay, the error was in a data loading or error was in a model building. In that way, you'll understand. So that is the way it will helpful. Okay. So execute line by line itself. Okay, let me go. Set. Okay. This is my data set. So I'm going to name it as, let me name it as. So these guys, see, these data set is going to be in a where means. So this data set is present in Keras itself. So I'm using that data set to train model. If you have any other data sets like CSV data set or it may be image data set, you can load using some functions. Okay. So then why I'm using this thing means, see, in this data set, we have n number of concepts. Like when you are getting this data set, the name of the data set is minis. So what is this minis means? Minis ఏంటంటే జనరల్ గా మీరు మీకు ఒక షీట్ ఇచ్చాను, షీట్ ఇచ్చి మీకు ఒక నెంబర్స్ రాయమని చెప్పాను, 0 to 9 నెంబర్స్ రాయండి ఒకళ్ళని చెప్పాను. సో మీరు ఒక నెంబర్స్ 0 to 9 నెంబర్స్ రాశారు. నెక్స్ట్ అదే షీట్ మీ ఫ్రెండ్ కి పాస్ చేసి తనని కూడా 0 to 9 నెంబర్స్ అలా మీ క్లాస్ మొత్తాన్ని డిస్ట్రిబ్యూట్ చేశారు. షీట్ ని మొత్తం డిస్ట్రిబ్యూట్ చేశాక సో ఎవ్రీ వన్ విల్ రైట్. సో ఎవ్రీ వన్ హ్యాండ్ రైటింగ్ ఈస్ గోయింగ్ టు బి అన్ డిఫరెంట్ ఫార్మాట్. ఒక్కొక్కరిది ఒక ఫార్మాట్ లో ఉంటుంది. సో ఇక్కడ ఏం చేస్తామంటే అలా కలెక్ట్ చేసిన డేటాని దే కాల్ ఇట్ యాజ్ అ మినిస్ డేటా సెట్. సో మినిస్ డేటా సెట్ we call it as. So that minis data set we are going to use, sorry, that interruption. So this is a minis data set which is going to be used here for a purpose. What purpose we are going to use this minis data set generally means to get this type of data. Means we are going to load this data. So like data going to have different handwriting digits numbers. I'll show that how it is going to be. Okay, I'll show you sample data. You'll get to know. Okay. So the MINIST is nothing but Modified National Institute of Standards and Technology. So they just created this data set that is named as a MINIST. Not only this MINIST, you will have n number of data in Keras. Okay, you can load that. So why I use that extrain underscore and underscore. This is the reason why this means. So while we are getting a data from Keras, we're going to get a complete data set. Data set is going to have like indicates, for example, you 10 people wrote digits. Okay, asked for 10 numbers again. So they wrote on a paper 10. Everyone wrote 0 to 9 digits. Okay, so I am going to make every zero, that 10 zeros in a one class with the name of zero. Okay. నెక్స్ట్ అన్ని వన్స్ ఒక క్లాస్ చేసి దానికి నేమ్ 1 అని ఇచ్చాను. నెక్స్ట్ సెకండ్ లో 2 నెంబర్ ని ఒక అన్ని 2s ని తీసుకెళ్లి ఒక క్లాస్ వేసి దాన్ని 2 అలా ఎవ్రీ వాల్యూ ఇస్ గోయింగ్ టు హ్యావ్ is name of the class. So here, while we are using for GANs, so no need of any names, because just we are training our model. Based on the training, it need to generate new image, right? So before training my GAN generator, I'm not going to specify which one is 0 and which one is 1. Okay, I'm not going to specify anything. I'm just training my model. That's it. Okay. So now what I will do, that is the reason. So X train will contain every features of the data, right? And Y train, what we will get? Y train we will get the label data. Means label means classes 0. This is 0 class. This is 1, 2, 3. Like that, we are going to have the 10 classes, 0 to 9 classes. So that is the thing. I'm skipped to Y. And also test. No need of testing for my data. So that is the things I also skipped to test. And Y test also I'm skipped, right? I need only features of my data. Nothing remaining. Just I'm not going to take care about any thing. Just I need. So from TensorFlow, because we use TF1, TensorFlow, complete using of TensorFlow, I'm using TF, okay, in place of TensorFlow. If you import keras as a KA, you can say it as a K. I'm just not that. I'm using keras. Okay, just simple. Dot. So data sets, okay, data sets dot minist. Okay, it's suggesting me as a minist. Okay, I'll go with the minist and load data. Yeah, it's done. Load data. So this is my data. Just I will load my data. Okay, now I'm going to have my data in this extreme. What I will do next, I'm going to normalize between -1 and 1. What is this normalization? See. For example, we have image like this. Let me show you some example. For example, you have a data, okay, like a 0 to 1. Let me show you first an image and I'll explain what is this normalization. Okay, let me do this first. -1 to 1. See, normalize between 1 to means why I'm using here means generally I'm gonna, for example, నా వాల్యూస్ ఒక ఇమేజ్ లో 0 నుంచి 2 to 255 వాల్యూస్ ఉంటాయి. మీన్స్ పిక్సెల్ వాల్యూస్ ఇమేజ్ లో ఇమేజ్ గోయింగ్ టు డివైడ్ ఇన్ పిక్సెల్ ఫార్మాట్. ఓకే, ఎవ్రీ పిక్సెల్ ఈస్ గోయింగ్ టు క్యారీ సమ్ నంబర్. ఓకే, ఆ నెంబర్ 0 నుంచి 255 వరకు ఆ పిక్సెల్ లో డినోట్ అయి ఉంటాయి ఎవ్రీ నెంబర్. సో ఆ పిక్సెల్స్ 0 నుంచి 255 అన్నప్పుడు ఇట్ మే కాస్ సమ్ థింగ్స్. ఫర్ ఎగ్జాంపుల్ 255 నెంబర్స్ అంటే నేను ఒకవేళ నేను ఫర్ ఎగ్జాంపుల్ 220 అనే నెంబర్ ఉంది ఒక పిక్సెల్. ఓకే, ఆ 220 నెంబర్ ని నేను ఇంకో నెంబర్ తో మల్టిప్లై చేయాలి. మల్టిప్లై చేసే నెంబర్ అది సమ్ లార్జ్ డిజిట్ అయి ఉండొచ్చు. సో ఇఫ్ ఐ మల్టిప్లై విత్ దట్ నెంబర్ ఆఫ్టర్ గెటింగ్ అవుట్పుట్ ఆఫ్టర్ డూయింగ్ సమ్ మల్టిప్లికేషన్స్ ఐ విల్ గెట్ ఎ హ్యూజ్ నెంబర్. సో అలా ఒకటి కాదు రెండు కాదు కొన్ని హండ్రెడ్స్ ఆఫ్ క్రోర్స్ ఆఫ్ నెంబర్స్ ని ఇట్ గోయింగ్ టు డూ is going to do some computation. At that time it need more computation power. అంటే చాలా ప్రాసెస్ చేయడానికి చాలా CPU memory and GPU memory యూజ్ చేస్తుంది. సో it time takes and also it will take much memory storage. సో to overcome that మనం ఏం చేస్తామంటే స్కేలింగ్ అప్లై చేస్తాం. ఏం చేస్తామంటే ఇక్కడ మైనస్ మన 0 to 255 ఉన్న వాల్యూని 1 నుంచి మైనస్ రేంజ్ లో దాన్ని సెట్ చేస్తాం. సో ఇట్ విల్ రెడ్యూస్ లెస్ పవర్. ఎందుకంటే ఇప్పుడు నువ్వు 0.1 ని మల్టిప్లై చేస్తే నీకు చిన్న నెంబర్ వస్తుంది. ఆర్ ఇఫ్ యూ మల్టిప్లై విత్ 30, 40, 200, 300 నెంబర్ యూ విల్ గెట్ అ హ్యూజ్ amount as a huge number as output. So to overcome that we are going to do this process. Okay, I'm going to use train. Okay, I'm going to use this parenthesis. I'll say why we are using parenthesis. Okay, extrain train dot as type. So as type, just I'm changing the type of my type dot np. Okay, np dot float 32. I'm using a float 32. So why I'm using here float 32 means this float 32 will help you to calculate and maintain the some values. Okay, it's not going to allow about to overcome any issues. So our computation will help us to do some calculations using this float 32. Okay, let me check something. Some errors. Okay, fine. I like this process. Now what I will do, just minus 1275. So why I'm using this 1275 means, see, after getting a value from this extreme, my each value should be in a range of 0 to 255, right? If I subtract 255 minus 127.5, I'll get the 125 as out, 127.5 as output. So getting that from here, I'm going to do 127 by divided. So what it will give? It will give me as a 1 as output, right? So I'll get the range between -1 to 1. So that is the thing. I'm just converting all the numbers to this scenario. I'm going to take again x train, okay, x train equals to x, so x train equals to np dot expand, okay, expand dimensions, okay, here it is, expand dimensions as x train, x, okay, x train, okay, as axis equals to -1. Okay. So what it will do some calculations and it will complete my data set values into range of -1 to 1. Okay. This is the thing is going to do happen in the using this float value. Okay. So it's going to calculate, it's going to give 1, and if the dimensions is going to take care, it's going to estimate between -1 every value. So that is the reason I used here, and I will use this one as buffer. My buffer I will use buffer size. Okay, I'm going to do it as size, that is size. So what is this size means? I'll explain what is the size. Okay, now I'm going to consider batch also. My batch TCH batch size. Okay, I'm going to use size. Batch size equals to, I'm not going to take that, I'm going to consider, let's see what is this buffer size means. The images which we are going to have in this data set, in the minis data set, are nearly 60,000 images we have. 60,000 images we have. So I'm just arranging for every batch size. See, for example, you are going for a movie. So I created, I'm not going to send one by one. What I will do, I'll make it as a batches. So me another movie keltunnaru, me group and then groups kin divided. So in the same way, I have 60,000 means I'm sending for each single batch as 128 students. In that way, 125, 128 image I'm passing for each batch. Okay, now I'm going to finish this data set, make it as a data set. Okay, so data set tf dot data set dot from tensor slice. Okay. So what this tensor slice, I'll explain. Okay. Extrain dot shuffle. I'm saying that shuffle. Okay, you will get to know. I think you understood, yes, right? Isn't it? So buffer batch size, as you can see, the batch size. So what happened here? Means, see, just I use TensorFlow data.datasets from tensor slice extrain. I'm passing all my this extrain data, and I'm saying that shuffle the buffer size. Use this buffer size. This is the size of the images and n number of images, and each batch need to have these 128. So while we are passing the like in a buffering format, so we're not going to get any issues, because see, if you send in a queue format, then model will not understand the pattern. It will copy something. It will copy the features and it will paste it in the same way. So at that time, we are going to get errors from our model. So to overcome that, what we are going to do, we are going to shuffle the images. So then at that time, what it will do, it will gain some knowledge. So there is a thing is going to happen using this buffer and batch. Okay, let me see this. Okay. See, the model has been when data has been downloaded, you can see it was from KS. Now just we use buffer, so 60,000 and 120. Is it clear, guys? Still here? So I normalized. So why we are normalized? We have compressed our data in a range between -1 to 1, because to overcome the computational usage of CPU and GPU. So we did this, and after that we reduce the size and buffer size as well as batch size. Okay. Next, what I'm going to do. We'll build the generator and discriminator. First, we'll start building the generator and discriminator. Just we have started building a models. Okay. Building to discriminator. Okay. Discriminator, generator and discriminator. So what this so we are so this is my generator. So this is my generator. I'm just taking my function. We build okay. So generally here model sequential, right? So I'm going to use the same model as the name as a model as sequential. Okay, a sequential model and just for that I need to pass some layers. Okay, for sequential model, see already I have said in a discriminate so before moving to GANs, I have already discussed about the CNN, right? So we're going to have some layers like convolution layer in that we are going to use. So in that we are going to use one of the layer. That layer name is dense layer. See, I use your dense layer, right? Isn't it? What is generally dense layer going to do means this dense layer, this dense layer, I'm going to define dense. Okay, I'm going to pass neurons to this dense layer. I'm going to pass neurons to this dense layer. So a number of neurons, that is my wish. I'm using 256 neurons. Okay, input shape. Input shape. What is the input shape? So it is specifying that input shape is 100. So why we took the 100? What is the reason for taking the 100? See, for example, you are training a model. You are training a model. Then the data which is going to come to the into the generator, because generator is going to accept noise data, right? It's not going to accept real data. We are going to pass noisy data in a 1D vector. So in a single vector, we are going to 100 data. It is not like a normal distribution or in a Gaussian distribution. The values has been generated. So that values we are going to use. Okay. So this 100 is going to pass. So after that, using this 100 points, we are going to connect with the 256 neurons. Already shown that image of neural network. So for example, we are taking 100 X points as a 100. Then it will accept it will connect that neurons with the 256 neurons inside in a hidden layer. Okay, so that is a dense layer here it is doing. And after the dense layer, I missed something, right? After dense layer, I'm going to use leaky ReLU. What this leaky ReLU will do? Leaky ReLU will convert all the information into standard. So I'm going to make this a 2. Leaky ReLU already we have discussed in hidden layers. Generally, we are going to use as a ReLU activation function. If you pass any value to the ReLU activation function, it will give output, same output. Means, for example, if you pass 97, then it will give output as a 97. If you pass any of the negative value of ReLU function, it will give it as a 0. For example, if I pass minus 97 to the ReLU activation function, it will give us as a 0 as output. So in such scenarios, what happens? You can't pass this 0 to next layer, right? Because it's not going to be an active state. The neuron is not working. Then how are you going for the next layer? Multiplication is going to happen? Not. So there only the neuron is going to be deactivated. So to overcome that issue, they introduced this leaky ReLU as activation function. So it's not going to give the exact value 0. It will give the 0 to 2 decimal values. After 0, it will going to give the two decimal values. So then the ReLU means that neuron is going to be not deactivated. So that is the thing they introduced leaky ReLU I'm using here. And again, I'm using one more dense layer. Okay. Sorry, already the thing is ready. Okay. Let me change something. Yeah, 512. Just I'm going to change this value as a 512. So now we have first one, how many numbers we have 100, right? Means in a vector we have 100 values, random values. So after the connecting with the neuron, it became 256. Now you are passing for leaky ReLU, will get output as 256. These 256 neurons is passed to the this dense layer. Okay. Now what this dense layer will do, these 256 neurons is going to connect it and make it as a 512 neurons. Now we have 512 neurons. That 512 neurons we are going to pass to the leaky ReLU again, and it will give the same as 512. Next we'll pass to the dense layer. So this dense layer gonna give us as input as 1024 neurons. We can specify n number of it, your wish. There is no limit based on your problem statement. And after that, we are going to use leaky ReLU. So why we used here 28 into 28 means generally this minis data set is going to have the values of image sizes, height and width of the image is 28 into 28, or else we can specify this is in the format of 784 if you want. You can mention 784 or 28 into 28 because you need to specify in the last layer the image size of the image, because generator need to generate exact how the new normal real image is going to have in that format it need to generate. So that is the way just we have did this. Okay. You will say that done. Okay. You're going to return model. So we're going to return the model. Okay, this is the thing is going to happen in a generator. Okay, then it's good for generator. Then what about a discriminator? Yes. So now we'll define discriminator. Okay, this is discriminator. So we are going to build the same as discriminator df BOLD build. Okay. Sorry, yeah. Build discriminator. Now we need to specify model, right? Model, okay. Just we're going to specify model, sequential model, right? So in that you need to specify flatten, isn't it? Flatten layer. So in this flatten layer, I'm going to specify then my image size. So input shape, my input shape data, because with this generally what this will do means it will learn, right? Discriminator will learn. So that is the reason I'm going to pass this image size 28 comma 28 comma 1. Okay. One is nothing. See, this is height and this is a width. So then what is this one? One is nothing but a representation of image color. Means we call it as in a term of channels. Okay, we call colors as a channel. So we have three channels or one channel. Three channel indicates RGB color. Okay, it will start from R and it will end with the P, right? Blue color. So this is the form we call it as, if it is a 3, then we call it as a RGB. If it is 1, we call it as grayscale because it's going to have only two colors, white or black, right? So now we are using images of white and black. So that is the thing we indicated with the one channel. So this is about discriminator. Okay, guys. In this discriminator, what we will do generally, we are going to reduce the size of image because it need to understand. So that is the reason we are going to reduce. So activation, I'm going to say specify the use activation sigmoid function. Why we use sigmoid? Because sigmoid going to indicate the binary classification. Binary classification that means real or fake, 0 or 1. So it is going to indicate, that is why we need to use as an activation function as sigmoid. Some space here. Okay. So this is a guys about model, just constructed model. Okay, next facebook.com. Where just let me check here. Okay. Invalid comma. Okay, I need some columns. Comma. So, okay, somewhere. Okay, this is about my model construction. Now, okay, just we have created a model, that's good. So, what about this last function then? So, we need to define a last function. So, why this last function? See, guys, you're getting in detail knowledge. So, if you have any doubts, just let me know. Okay. Is it clear? Am I audible, guys? Okay, that's cool. Just now we are going to just let me set up a loss. Okay, what is this loss function? Just guys. Okay, so let me set up this first. Okay. Set up loss function. Okay, what this loss function optimizer means. So when we are going to do we are going to calculate a difference. So this is a real or fake image. Discriminator going to calculate this is a real or fake. So based on that, it's going to give the option to us. It's going to give the output which one is fake and which one is real. So for that we are going to use loss. Means see, generally we have real one. So when the generator going to generate fake one, it will understand. So real image going to have some features and loss is going to have some features. So based on that two features, it's going to define some loss. It's going to give some differences. The difference is nothing but loss. So we have to use binary cross entropy for that. So which is going to generally calculate this loss function for any of two. If you have, if you want to calculate between two things, yes or no concepts. So here we have two things. One is real or fake. We call it as a 0 or 1. In that scenario, we're going to use this binary cross entropy. Okay. So first we'll check the generator loss. Okay, generator loss. Generator optimizer. So what is optimizer? What this optimizer will do generally means optimizer is nothing but, for example, మీకు ఆల్రెడీ లాస్ వచ్చింది అంటే రియల్ ఇమేజ్ తెలుసు ఫేక్ ఇమేజ్ తెలుసు బట్ మన డిఫరెన్స్ ఎంతో తెలుసు. సో ఈ లాస్ ని బేస్ చేసుకుని మోడల్ ని మళ్ళీ ట్రైన్ చేస్తాను. అంటే నువ్వు ఇంత లాస్ ఇచ్చావు సో అప్డేట్ చేయ వాల్యూస్ వెయిట్స్ అనే కాన్సెప్ట్ ఉంటుంది. సో దాన్ని మళ్ళీ ఈ లాస్ ని బేస్ చేసుకుని ఆప్టిమైజర్ అనేది అడామ్ optimizer మనం జనరల్ గా యూజ్ చేస్తాం. ఓకే, సో యూజింగ్ దట్ అడామ్ ఆప్టిమైజర్ వీఆర్ గోయింగ్ టు అప్డేట్ అవర్ మోడల్ వెయిట్స్ మళ్ళీ అప్డేట్ చేస్తాం. మోడల్ ఇంకొంచెం స్ట్రాంగ్ గా ట్రైన్ అయ్యి ఇంకొంచెం అక్యురేట్ గా అవుట్పుట్ ఇస్తుంది. సో దట్ ఈస్ ద థింగ్ వీఆర్ గోయింగ్ టు యూజ్ అడామ్ హియర్. ఓకే, అండ్ వాట్ ఈస్ ఎల్ఈ ఈజ్ నథింగ్ బట్ లెర్నింగ్ రేట్ అంటే ఏంటంటే జనరల్ గా వీఆర్ గోయింగ్ టు స్పెసిఫై దట్ ఈ ఇంత ఫామ్ లోనే లెర్న్ అవ్వు అంటే ఎక్కువ స్ట్రెస్ తీసుకో. మీన్స్ ఇఫ్ ఇట్ ఈస్ లెర్న్ మోర్ కాంప్లెక్స్లీ will face issues. So that is the thing we are going to specify the learning rate. And see, consider 10 images only. Okay, extract and understand features from that images, 10 images. Next, go for the next 10 images. So in that format, we are going to specify this learning rate. The learning rate ఎంతో తక్కువ తీసుకుంటే అంత స్లోగా మోడల్ అనేది లెర్న్ అవుతుంది. ఇఫ్ యూ స్పెసిఫై హ్యూజ్ మీన్స్ ఫర్ ఎగ్జాంపుల్ మీరు ఒక 10 పెట్టారు అనుకోండి, ఎవ్రీ టైమ్ 10, 20, 30, 40, 100 ఇమేజెస్ కన్సిడర్ చేసింది అనుకోండి, అందులో కొన్ని ఫీచర్స్ ని క్యాప్చర్ చేస్తుంది, కొన్ని ఫీచర్స్ ని వదిలేస్తుంది. So to overcome that scenario, we'll keep as a learning rate as much as less. Okay? Learning rate is nothing but the model, how fast it understands. Okay, so based on the given number, it is going to understand the learning rate. So this is about learning rate. And optimizer, generally we use that as a process for optimizing. And now we are going to define training step. So just we are created model here, model train the first one. So for training purpose, I'm going to create training step. Okay. This is my training step. In this, I'm going to define at the rate one decorator, which is going to help to things like work out leda, everything need to take care. So for that, I'm using this some decorator. Decorator is nothing but in function we are going to have some flows ante oka dantlo okani packages ni pack chestuntam. So in such scenarios we are going to use this decorator. Okay, train step. Okay, this is my function, just a new function rasuna train step ani. Okay, I'm passing my images, here. Okay, you see guys, this is the parameters. Okay, you can give what are the name you want. So first I'll pass a noise. Okay, noise data, TFS random normal. So using normal distribution, my batch size is 100, nothing but we are going to use 128 images. So 128 images, each one is going to have 100 vectors. Okay, so this is my batch size. Okay, next I'm going to train. First I'm going to train discriminator. Okay, generally what we need to pass to train discriminator, guys, according to you? Shall I pass this noise? It will accept. It is just providing just how work this tf dot gradient. So what this gradient will do means, so in TensorFlow they are providing gradient ఎందుకంటే ప్రతి లేయర్ అక్యురేట్ గా క్యాల్కులేట్ అవుతుందా, వర్క్ అవుతుందా లేదా అని చెక్ చేసుకోవడానికి ఫర్ జనరేటర్ పర్పస్ దే హావ్ గేవ్ దిస్ ఆప్షన్ యాజ్ ఏ tf dot gradient. So it will help us to is every layer is working properly or not. It is going to check by using this gradient. Okay, see here they give us a discrete. Okay, so it will suggest for us discrete tag. Okay, so now generated images, we are going to pass generate noisy training for generated images. Okay, for generating images we are going to pass noisy data, and it is we are saying that this is a training purpose. True is nothing but we are training the model. So we are passing noisy data. This is randomly. So no random, just we are using random function here. So with the normal distribution. So these values and a vector, for example, consider line 100 line. So ala మనం బ్యాచ్ సైజ్ అంటే 128 1200 నెంబర్స్ మనం పాస్ చేస్తాం ఒక random noise. Okay, so but it will pass single random vector, సింగిల్ వెక్టర్ ని పాస్ చేస్తుంది, 100 వాల్యూస్ ని ఒక అటెంప్ట్ లో పాస్ చేస్తుంది. ఓకే, మోడల్ కి. కన్సిడర్ గైస్, ఇస్ ఇట్ క్లియర్? అండ్ నెక్స్ట్ రియల్ అవుట్పుట్. ఫస్ట్ we are training discriminator, right? Training a discriminator, we are passing our images. Okay, we are passing images here. From here we are passing images and we are saying that train that. Okay, it has been trained and it will give the real output. Real output and ఎలా ఇస్తుంది, like రియల్ ఇమేజెస్ కి అది ప్రాబిలిటీ 0.9, 0.8, 0.99. సో ఇలా ప్రాబిలిటీ ఫేస్ చేస్తాం. అండ్ డిస్క్రిమినేటర్ ని మనం ఫేక్ ఇమేజ్ కూడా పాస్ చేస్తాం. మీన్స్ జనరేటెడ్ ఇమేజెస్ పాస్ చేస్తాం, ఫేక్ ఇమేజెస్ జనరేటర్ అంటే నాయిస్ నుంచి జనరేట్ అయినాయి. and will pass a training. And it will understand how to predict. Means, see, ఇప్పుడు నీకు చెప్తేనే కదా దిస్ ఇస్ అ క్యాట్ అండ్ దిస్ ఇస్ అ డాగ్ అని నీకు ఎన్ నెంబర్ ఆఫ్ టైమ్స్ చూస్తే విల్ అండర్స్టాండ్ ఓకే దిస్ ఇమేజ్ బిలాంగ్స్ టు క్యాట్, దిస్ ఇమేజ్ బిలాంగ్స్ టు డాగ్. సో ఇన్ that same way we are specifying that this is a generated images. Discriminator will understand on difference between the generated and the real data difference. It will understand, so it will finalize this is a fake output. So when it will finalize fake output, ఏవైతే ఇమేజెస్ కి లెస్ ప్రాబిలిటీ ఉంటుంది 0.3, 0.2, 0.5 ఇలా ప్రాబిలిటీ ఉన్న ఇమేజెస్ మొత్తం ఫేక్ అవుట్పుట్ కింద కన్సిడర్ చేస్తుంది. ఓకే, సో దిస్ ఇస్ ద థింగ్ గోయింగ్ టు హ్యాపన్ ఇన్ అ డిస్క్రిమినేటర్. Now what we're going to do, so I'm going to say that real cross entropy. So I'm taking real output is equals to F1. So I'm going to say that cross entropy, not TF1. Okay, I'm going to say that cross entropy TF1 like real output and real image. How you get to know? So let me explain that. Okay. Cross entropy. So what is cross entropy? We are saying cross entropy means this one. So we named it as cross entropy for binary cross entropy. Means it will define real and fake images. It will understand the difference between real images and difference between the fake images. So we are providing for our loss function. Okay, we are specifying for our loss function. Now what you'll do, di fake plus loss of guys, it will defocus. Okay, now what we're going to do, this tab generator, this class discriminator and train variables. So we are specifying that to discriminator to understand the specification variables. Okay, we are just I'm going to change the name of this. I'm going to change it as discriminator. I'm going to change it as DISC disk. Okay, DISC disk grad. Okay, I'm going to specify this grad means nothing but discriminator. Okay, grading. So I'm going to pass this tab gradient and this class and means discriminator loss and specifying and discriminator trainable variables. Nothing but we are going to get the accurate, means it's going to understand information from variables. Okay. Next, optimizer, discriminator optimizer dot apply gradient. So what are the things we got? We are going to apply on the real function. We are going to apply on the real function. Let me change the name here also. Gradient. Okay, let me change completely. DISC. Okay, disk. Disk grade. Okay, disk grade I'm going to apply. So I'll get to know that variable. So this is a thing we are going to train. While training, the model will understand. Guys, it will look somewhat clumsy. Just try to understand. Okay, just going to exit. I'm going to write some more here. Okay, and now I'm going to train a generator. The concept looks quite difficult for you because it was the first time. So you'll need to learn a number of times, then you will get to know. Guys. So I'm going to train the generator now. So see, I just is suggesting from your report. Okay, with FT means TF here, and the last time what we gradient tap, right? So in the last we have seen that gradient tap into this tab. So now we are doing gen tap. It is knowing that we are just using a generator. We are training our data with the generator. We are using from gen tab. Okay. Now same as in the previous only, we are going to train our generator with the noisy training data. Yes, isn't it true? And the next we'll go for the fake output, means discriminator get to know this is a generated images, then it will understand. Same as now what it will do means gen loss, we are going to use cross entropy. Cross entropy. It's suggesting So T of like fake output, right? To check the fake outputs, and it is going to check the same as how we have just checked here in the real one. In that way, we are going to show our model that this is a fake, means gen loss. After that, it will check with the gradient descent and it will update the weights every time in the background to regenerate images n number of times. Okay, guys, is it clear till here? I think it's clear. Okay. So this is a thing about just let me right. After doing this, what we need to do? Okay, it worked well. So we need to return discriminator loss and generator loss. Yeah, we'll get to know discriminator and generator loss. Let me run this. Yeah, it's clear. Okay, guys. So it is looks like clumsy. What this general ఏం జరుగుతుందంటే మనం జనరేటర్ ని నాయిసీ డేటాతో ట్రైన్ చేసినప్పుడు అది కొన్ని ఇమేజెస్ ని జనరేట్ చేస్తుంది. ఆ ఇమేజెస్ ని మనం డిస్క్రిమినేటర్ కి పాస్ చేసి డిస్క్రిమినేటర్ ని కూడా ట్రైన్ చేసి అప్పుడు డిస్క్రిమినేటర్ ఏం లర్న్ చేస్తుందంటే రియల్ ఇమేజెస్ కి ఫేక్ ఇమేజెస్ కి డిఫరెన్స్ ఏంటి అని ఫైండ్ చేస్తుంది. ఓకే, ఫైండ్ చేశాక మనం దాన్ని ఏం చేస్తామంటే అదే డేటాని మనం లాస్ కి సేమ్ క్రాస్ ఎంట్రోపీ యూజ్ చేస్తాం, విచ్ ఇస్ గోయింగ్ టు ఫైండ్ ద లాస్ బిట్వీన్ రియల్ ఇమేజ్ అండ్ ఫేక్ ఇమేజ్ ప్లేస్ లో మనకు లాస్ ని ఫైండ్ చేస్తాం. ఫస్ట్ టైం రియల్ ఇమేజెస్ కి లాస్ ఎంత వస్తుందో ఫైండ్ చేస్తుంది అండ్ నెక్స్ట్ ఫేక్ ఇమేజెస్ కి లాస్ ఎంత వస్తుందో ఫైండ్ చేస్తుంది. ఆ రెండింటిని గ్రేడియంట్ డిసెంట్ అనే ఒక ఆప్టిమైజర్ కి ఇచ్చినప్పుడు ఆప్టిమైజర్ క్యాల్కులేట్ చేసి వాల్యూస్ ని వెయిట్స్ ని డిస్క్రిమినేటర్ లో జనరేట్ మీన్స్ వెయిట్స్ ని అప్డేట్ చేయడం వల్ల మోడల్ ఇంకొంచెం స్ట్రాంగ్ గా అండర్స్టాండ్. సో దట్ ఈస్ ద థింగ్ ఇన్ దిస్ డిస్క్రిమినేటర్ యాజ్ వెల్ యాజ్ సేమ్ యాజ్ ట్రైన్ జనరేటర్ ను కూడా అదే విధంగా ఎవ్రీ టైమ్ ఇట్ విల్ అప్డేట్. ఓకే, ఇస్ ఇట్ క్లియర్? Now what we're going to do? So okay, we are going through it. Okay, fine. Then what about training our model? So we need to train, right? So before that, I'm going to paste some code that generated images I'm going to store somewhere. Okay, let me write it as generated and save generated images. Okay, let me add some meshes. So okay, now I'm going to add some generator loss. So like this, track my losses, means every time నేను ఎంత లాస్ చేస్తున్నా అనేది నాకు ఎవ్రీ ట్రాక్ లో రావాలి. ట్రాక్ ఇన్ ద సెన్స్ I will let you know. Just a minute. What is this track? I will let you know. Okay, now let me change this. Not list. Losses is fine. Yes. Okay. This is my loss. Okay, I'm going to specify directory for saving my images. So where will save, or what is this means? I will let you know in the next slide. Okay, just wait for generated images. Okay, here I'm going to use os dot. So mock diaries. So generated images, I'm going to exit okay to okay. What is this? I'll let you say no. And I'm going to define one function. I'm going to define my own function. Generate and yeah, it's already showing for me. Save. Okay. Save images. Save images. I will just model epoch test and input all these things we are going to get. Yes, right. So my figure size must be 5,5. It looks better compared to other images. It looks 5 better. Make it as 0.5. So you'll understand what this 0.5 in the next step. Okay, wait for a while. And for range of 25, shall I take 25? I'll do one thing. Range, I'll make it as a range. Prediction. What is that? Right. Prediction dot shape. Input shape or shape? Shape is prediction. Yeah, prediction shape. But yeah, we're going to work definitely. We can check that. 5 plus 5, yeah, the image size parts of plot. And next, I'm going to plt dot. Okay, show that axis must be off. Okay, so what this generally, wait for a second, just a minute, I'll let you know. Image epoch, and yeah, let me remove this. No need of PNG, I'm going to make it as where this all things is going to be saved. OCH epochs, sorry. Epoch, okay, epoch dot, I think this is the right command, yes. Okay, let me give this 0 or 3D inspect. Okay, but there is a kind of error here. Format no need now. We can give whatever thing you want. Okay, it's fine now. Now what happened here? I need to check, right? Images. Okay, let me remove this then. So generated image as image at epoch not just epoch is fine. Image epoch at the value of dot png, right? Epoch column 0 3D, right? Yeah. Now what you're going to do? Just you need to plt dot show, means it will show an image on plt dot close. Okay, just this. Yeah. So why I'm used here, why I saved means I will let you know. Just next code I'm going to write. Okay, what I'm going to do, I'm going to add execute. Okay, execute the training loop. Okay, training loop. So, right. Okay. So what we need to here, we are going to I'm going to take def trin train function data set, comma, approaches. Okay, I'll specify my approaches as I'm just defining here itself. You can define if you want, you can pass. This is the default, okay. And next, I'm sending. I need to give seed, okay. Seed equals to tf dot random. So, do you know what is meant by seed? Rand normal I'm going to use, not random normal. Okay. Yeah. Random dot normal. Yeah, random dot normal. So I'm specifying this fixed node. See here, seed is nothing but we are specifying the random size. Means we are passing 25 images. 25 images. Each one image will carry 100 numbers. So that is a seed is going to specify to the generator. Okay. While it will going to train on this and it will learn. Okay. So that is the thing we are passing seed here. Okay, data set we are passing, we are saying approaches. So what is mean approaches are? Generally approaches is nothing but n number of times the loop need to be rotated. Means if I pass an image, it need to extract some features, right? At that time it is going to understand the features, it's going to understand the features. Okay, let's see after training our model how it is going to look like. Okay, let me go one thing. Just we have created loss. See, we can generate loss, discriminator loss. So train step we are getting, see, from train step, like where we created train step here, right? Here, this is a loss function. For loss function we have created, and here we are training our model and we are getting, see, let's see how this going to work. Loop, yeah, loop in loop. Okay, now we are going to gen loss, right? Gen loss dot numpy. We are going to use numpy. In this class is this numpy, and print we are not going to use if condition. Let me no, just I'm going to check that print. Okay, print, yes, approach one and generator loss. Let me check that we use generator or gen loss. In a discriminant disk loss and generator and save images as generator plus. Okay, let me run this. If we get output, right? Okay, the function is working correct. Let me check that it's working or not. Train. Let me run my function as I'm passing data set, right? Data set, comma, approaches. I need to pass approaches, right? Approaches equals to, I'm asking for 50. Just let me run this. Got an error. Name generator is not defined. Generator, it has not been defined. Let me check that once. Just let me check that save in images, right? So here we need to check in the images with the generator name. What the name we used here? Generator and save images in the place of this. Save images we are passing here. Model, we are passing model, but we are specifying that generator is not defined. So we are calling this function means where we haven't specified where I have. Just a minute, let me check. I have called any of data means model or not. Just a minute. But already I specified generator, then why this showing an error for me? Sorry, guys. Really, discriminator and generator. Just a minute. I'm just checking that. Where is that error? Go to subject license. Hey, Ganesh. Yeah. Sorry for that, just I forgot to all these functions. Just let me check that. So yeah, I forgot to call this. Just it's done now. Let me rerun it once again. It's work. It's it is going to work. Yeah. So for that, but what is the creating variable is the one for scope function is the T function. Functions creating variable. Okay. One first call function decorated. Yeah, it's coming. Hello. Yeah. I will improve. What? No. అలాగే నేను చెప్తా. See, okay. Just let me try it once again. I'm just placing the result. Just clear this one. Yeah. So that is issue with the variable. Just I changed that. Now, see guys. So what we did. So just we use n number of epochs here. N number of epochs as 50. So I used 25 images in 100. Okay. You're going to have each vector is going to have 100 random noise, random normal distribution values. And it will take each and it minimize batch and data set. And it will train, go to the train batch here. It will start working on the images. It will train the model, and it after doing each and every epoch, it's going to show us what is the last epoch of each one, and every time it is going to update it, and it will place as generator loss as gen loss, the four decimal values, and the discriminator loss as well as, and the image where we have saved, no, this is the thing, what where I wrote, and it will call this function generator save image as generator epochs plus seed. It will go here and it will display the each image. So while see, you can see how this generator and discriminator are generally learned. So you can check the loss. It is going to update it every time. The loss is going to be updated. You can see this is the noisy data. Can you differentiate anything from these images? You can say just are you able to say something what these images are describing about? Each one is one image, guys. Each one is about one image. No, right? So after moving each one epoch I said no means one time it will deal with a set of batch, set of group of images is going to train on this discriminator as well as generator. Now generator will take the noisy data and start generating. So you can see if we move for the second epoch, it has been came somewhat closer. See, just it was same again. It has been spreaded. So it's trying to analyze. You can see each and every approach. You can see it is trying to analyze something from each layer, right? So like this, we use 50 epochs. So we need to wait till 50 epochs. Based on the overview of these images, we are going to set things. So every layer you can observe that it is trying to predict something. It means it is trying to generate the images, understanding the images. So I already said that we are using a minis data set where we can go with the handwritten digits. Okay. So here we're going to get the digits of different handwritten digits. So the model is learning by each and layer by layer. So we need to wait till for 50 epochs. Okay. So if you want, you can just increase that to 100 based on the given value. So from here, the layer from epoch 20 on 19, you can see that images started getting updated. So we can observe some numbers in that slides. Slightly we can observe, right? So it's when it is moving somewhat forward, surely you're getting images, right? Is it clear? This started from noisy data. Now how it is working? It's a thing about GANs, right? Till 50 we got, this is the output. Okay, now let's check that once what is the final result and output from this images. Okay, what is the final output? Just let's check once. Okay, for that I'm going to ask for my model to give the evaluate the discriminator. Okay, I'm going to evaluate the discriminator. So just so I'm specifying the TLT dot. Okay, I'm going to ask for figure. Yeah, figure and generator loss. So let me check that generator loss. Okay, and label as discriminator approach. So gen loss is okay, disk loss means the discriminator loss and epochs, and finally we'll get the training loss. Okay, title it as a training loss. It means that I'm just going to add it. ELT dot title as training loss. Let's see. Legend, it's fine. We'll ask for grid. So shall I go with the grid? Let's check grid and off of the turning of the grid. Okay. PLT dot. See that loss started here and gone up till 4. Okay. The discriminator loss also it has been in a constant way. We can check it is nearly 1. Whereas the generator loss is quite high but came near to 1.8 or 1.9. So we need to reduce some more the discriminator loss. Okay. It need to be a sorry generator loss. It need to be near 1. It's a good one. So it will understand. You can increase the epochs, n number of epochs, then it is going to work. Okay. So let's check the final display. Check the image. Okay. Right there. Display generated images. Okay. We check that. Okay. I'm going to noise is equals to tf dot random normal. Okay. And the generated images generated noise. Okay. I'm just passing to generator to generate this. Okay. After training, right? Figure equals to I'm going to plot it that figure what the output I'm going to get. It's fine. Yeah. Place range. Okay. It's not good. Next plt dot image show. Okay. Image show generated images. Right. Generated images. We need to display generated images in the form of dimensions. We need to specify, and after that we need to specify the this one, right? So numbers we are just adding this one and a grayscale. You can see this is the image size, height and width, and after that we are passing the channels, and after that we are seeing it's a color is a gray. Okay, pixel is on off its wish. It's not that thing. I'm going to write layout. Okay, I'm going to add subtitle. Okay, I do that. PLT dot. Okay, subtitle as final generated image. Okay. So these are the final generated images. Okay. Display. I need to run. I need to say the image. I need to call the function of display generated images. Okay. Now let's call this function. See the output. Let's wait for a second. I think there is a no TP was to enter. Okay. Then what is the thing? Generated noise images. Okay. Let me do one thing. Let me run this. Then yeah. What happened? Yeah. Okay. Let's check that. Is it correct or not? This is the final generated images, guys. So this is the generator where it is generating images based on the noisy data, right? So this is about things. If you want to evaluate like discriminator, also you can evaluate using like evaluate discriminator. Just let me show that. It is going to say that what is the real image accuracy and the fake image accuracy. Means see the generated image and the real means data images. If you want, try just you want to show that. I'm going to update it that here. Evaluate, evaluate. Okay. Um, evaluate. Okay, just DISC. Okay, this is my function. Noisy, I'm just asking for noise or random data. Okay. Noisy, is that noise equals to TF, right? Not random. So it's just generating. Okay. Need to check it a number of times. After that, guys, see images. Okay. Just the real images equals to next. Make some mistakes. Okay. Right. Okay. Now, what it is going to do? Okay, just let me check once because we bundled it on this file. Yeah. Now I need to do the same thing, but I'm going to copy this. This I need to do for my reduce the mean. Okay, real accuracy. Okay. So to evaluate, we are going to use this tf dot cap. So which is going to give the actual output and the things. Okay. Cast if cast and real output is greater than this value, then it is the model is a working good one. And next we are going to print, right? We're going to print real accuracy, right? Discriminator real accuracy and discriminator fake accuracy, right? Evaluate this, right? You can see what is the real accuracy 8.1 and the fake accuracy also 8.2. It's a near, right? So that is a good one. The model is working the good one. So like this, you can create your own GANs network. Not only GAN, you can go with the transformers and various encoders. So once it will look like somewhat clumsy. So if you work with the a number of projects, you will get okay. How was the session today? Is it good? Okay, let me. Name error. Just go and call that. I forgot to call that as a thing. Generator, right? Yeah, just call that function build a generator. And I forgot that. Okay. Yeah, it's done. You can evaluate and you can just go with your can create an application like Streamlit. And in upcoming sessions, I'll show that how to create this Streamlit, and you're gonna work to create chatbot too. But there we will use directly as a pre-trained models. Okay, here we have just created our own model generator and discriminator. Okay, I didn't get one complete or what is that? Praveen Kumar. I didn't get the question. Just read it again. And okay. So, do you have any queries about coming to everyone? Yeah, I'll share code that file in a group. Yeah, yeah. Okay, I will let you know, guys, on Saturday what about the project. Complete every detail about the project and Saturday session. Okay, you'll get to know in detail, and or else I'll inform on Friday. Okay, you can just get all the things in Saturday. Okay, and just inform about our projects, what you are going to do. Okay. For accessing the resources, we're going to share through the links. Okay. Okay, you want complete code? I just made a question. Okay, I'm going to, yeah. So first, what we are going to do, we are going to import all required libraries like NumPy, TensorFlow, and TensorFlow. In that we have different layers, flatten, reshape, leaky, relu, sequential, and matplotlib, and the operating system. Now we are going to import our data set from Keras. Okay, it's a mini data set. Okay, that's good. And we are that is nearly 60,000 images, and the each batch contain 128 images. Okay, in the way we are going to train on that, and this is a generator. So we have same, if you are good with the CNN, you are going to get all the these are the CNN layers. Depth layer we use, this is a leaky rail. And in this, do you know, we are going to add some errors. So if you are getting huge loss, you're getting huge loss then compared to the discriminator. So what we'll do, just we will add some dropout layers in this generator and discriminator. So you need to just overcome that. You need to do this generated, build generated, and you need to call this function and forward this. Okay. Yeah, I did it here also. And next, what we need to do, and just cross entropy, which is going to deal with the loss function. So generally మనం ఏం చేస్తాం, మన లాస్ వస్తుంటది. So the real image ki fake image ki difference వచ్చేది loss. We call it as a loss. So this binary cross entropy will decide that one. Means what is the loss? Okay, this is going to have the formula that based on that it is going to decide the loss. A loss optimizer key. I mean, Adam is going to take that loss and going to update the values in the background. It will update the neurons weights. Okay, it will update the neuron weights, and the model will learn that accurately. Okay. And coming to the this training step, every time we are going to train our generated with the noisy images, then it will learn something. Discriminator is going to train with the real images. Okay. Just after that, we are going to get the fake output. Means the real output, nothing but it's going to get. For example, you get the for real image, you got the probability of 0.9. Then it is going to consider, okay, this is a good image. If that image got probability was 0.2, 0.3, then it is going to consider it as a fake image. That way. Okay. After we are going to get the loss between real image and the fake image, we are going to add it and make it as a complete discriminator loss. So this is a complete discriminative loss. And we are going to pass to the gradient descent. Gradient descent is nothing but loss function. Okay. So you can see the here optimizer we are using again. So that is the thing, we are going to update the weights and we'll say that learn more. For generator also same process, we are going to do that. We say that this is a noisy data and it will pass generated and we'll get the fake output from the discriminator and pass to the cross entropy, and it will understand based on the cross entropy and we'll update the weights, right? So this is the thing, it is going to finally going to give the loss, what is the loss and discriminated loss. The finally for images, to get all these images going to save and the size, we have wrote this code for every image, what is the size and what is the structure and what is the follow. So we are using loop by loop and we are adding this. So we'll get all the information from this, and we are going to train our model with the noisy data, and every epoch what will what it is happening we are going to see here. Okay. So it's going to start with the noise. You can see in the top, you are not going to know what is that you have in that image. So, but final after 50, you can make it as 100 also if you want to. Yes, so after that, we are going to check that loss. Means what is the accuracy, means how it has been performed. We can check the loss. So loss gradient started here and it is being decreased. See, so if you increase, it may decrease. Okay, you need to take care about that. Finally, this is the generated output. Again, we pass this to the generator. Now generator has been trained, and now we can pass the noisy data. Then it is going to generate like this. Okay. And this is about what is the real accuracy and fake accuracy about the image. Okay. Attendance, yeah. If you join that, you will definitely get an attendance. Okay. Yeah, I'll share that. Just unshare this. I think facing some internet issues for the glitches. Sorry for that, guys. Okay, if you are not getting that code, just leave that. Just I will show that how the IBM is going to. Now you have a basic knowledge, right? Where we need to do and what are the things we have in IBM, right? So just that is the reference purpose. While you are doing the project, you can go through the hugging phase. Okay, I'll show that how to do. Okay. Okay. See, if you send the mail, just write the mail once again. You will get definitely he's going to reply, but it will take some time because he's busy with some works like other works. So he's going to get daily a number of mails. So please wait for. So you can add a number of epochs that is based on that. So you can, if you are not interested to see that visualization, you can just stop printing. So then you will not going to get any images. Directly you're going to get the loss of that each layer. Okay. Yeah. If you increase that 100, then it is going to give 100 epochs. To understand nothing is that just see some tutorials like how they are working. Go to GitHub and just explore. Every code is going to start with the basic coding. It's like write the simple code, like go with a deep learning model or take any model. It will can take 10 to 15 lines of code. Write that code, work on that project. So if, for example, if you want to learn more, just go for first start with the machine learning. So you're going to have every part. It is going to have different parts. You're going to start with the getting data from outside, like you have the Kaggle website, so where you can find the data sets, a number of data sets. So there, go there and just get the data set and just use some command like pd.read.csv. This is a command for load this text data. Okay, so load the data and observe something like what are the things we have. Like do EDA. Okay, first you need to do EDA, means you need to visualize that scatter plot. Visualization, you need to do the data. So write that course. Try to write. Go to some websites. Try to understand what are the codes I need to write. So write for that to 5 to 10 data sets. Then you will understand. You without seeing any of code, you can write EDA. After doing EDA, do this process like removing the missing values from the data set. For that, you're going to have some commands like is null values. So functions, you're going to have a lot of functions in Python. So try to do for that n number of data sets. So now you are clear with the EDA and you are get to know about that uh, clearing null values and missing values from the data set. Now use that data set for training purpose. So write for decision tree. It will take 5 to 10 lines of code, and write for SVM, and write for next what we have random forest. So like this, write code for n models in a different projects. Like take 3 4 projects and write for every project. So you will get a good idea and good knowledge of the code. And next, go for deep learning. Do the same process. You will get to know deep learning. After that, you will get this generative all these things. All the code is going to have in your fingertips. Okay. You're welcome. Yeah, basics that start with the machine learning, deep learning. That is a basic thing, and go for the next generation. Okay. Ukendranath, what is your question? What's the question, Lokendranath? Right? You will get certificate from IBM, guys. If you finish that self-based course, already I shared. I'll share one more course tomorrow. Okay, you need to finish that course. Finish what are the course we are sharing. I'll share all the templates today or tomorrow. I'll share a link and with the course name. Open that link and just go there and finish that course. Okay. What is your question? Let me know. I'm going to clarify. No. Okay, leave it. If you have any issue with the creating IBM open, just guys leave it that. Okay. Just I'll just you will get to know that how to do that. Just create account in skill builder, right? IBM you have no. Just do that and finish the self-paced course. And next, I'm going to show that cloud things. Okay, don't worry about that. For account creation, if you are okay, then you can create. Otherwise, you can leave because you're going to work with the Hugging Face, the same model you're going to work with Hugging Face. I will explain you about what to do, the complete steps, project steps. Okay, what complete things I'll explain. Okay, about internship. What are the internship you are doing? That in that phase, we'll get that generated with IBM Cloud. You will get the certification. Not the what's next. You will get the generated with IBM Cloud. In this format, you are going to get the certificate. Okay, guys, I'm just clearing, I'm just saying that about project and the groups and the process steps for project. I'll explain all these things on Saturday. Okay, in Saturday session, I will explain everything what you need to do, how to do all these things. Okay, if you are not getting cognitive code, just leave it. Cognitive AI code, just leave that. Okay. Try with the other mails. If you get, it's fine. If not, just leave. I said that try with your normal mobile internet. Try it with the other mail. If you are getting issue with the one mail, you can try. If not, just leave that. We'll go with the Hugging Face. What do we get IBM certificate? What's on no, I think you didn't get. We are not going. We are not going to provide any vouchers for exams. Okay. I think if there anything, I will let you know. Okay. Just wait. You will get receive the all mails. Okay. Surya said that don't post it a number of times. Okay. Hmm. Coming to the project, I said that I will inform you. I'll inform that about batches. Okay. Already shared the link in the group. I'll just share that links. Okay. No, it's not a problem. Just the mail. Check your mail. With the mail, it is okay with your mail. Then it is not going to affect your attendance. Okay. Yeah, I'll share code with you guys. Okay. Don't worry. How was the session today? You got some practical knowledge on the GANs. Is it? Tomorrow I'm going to explain some sequential models. Okay, so we'll discuss about sentiment analysis, these things, and after that I'll just show that how to create chart. And do one thing, guys. While I'm doing, just do with me. Okay, you will get some knowledge and as well as we'll get some doubts too. Okay. So if you have laptops or with the all everything is good, so go with me. So how just while I'm writing code, just go with that and do it as soon as possible. So you'll get a practical knowledge. Okay. Yeah, I will let you know, guys. Hugging Face is quite easy. No need of video. I'm going to explain you in the next end of this Friday. I think so. Will discuss Thursday and Friday about this chatbot completely. Okay. Sorry for that voice. Somewhat glitches happen due to internet issues. So I'll talk with them. Just sorry for that. From the next session, you are not going to face that any issues. Okay. Still, you are facing issues with the voice. Yeah, it's fine. So if you are using that is not a good way.